Google slide is attached here for your reference, but I do not want you to use it on the quiz. I want you to just use your own brain and your own awareness of what integers are and how they act and sort of how they're arranged. So you can use this to study and prepare, but it's not something you should have access to or have open when you're taking the quiz. And I'm going to walk you through the quiz. You'll be surprised that it's really straightforward, multiple choice, not too much calculation involved with integers just yet. So the other thing that's attached here is a little worksheet that we're going to go through for guided practice. Just real quick, I think I saw Riley on here. Riley, you here? I saw Leah. Paige just came on, okay. Leah, are you there, honey?
Yeah, I'm here.
Okay.
Okay. Yesterday, I don't know what happened.
Okay. I just want to make sure you can see and hear me. All right, so I'm going to get this document open and shared with you so that we can start to write on it. And what we're going to be modeling here first are some number line integer equations. And our procedure for this is going to always start our cursor at the 0. What's another name for that position? What's another name for that spot? Go ahead. Anybody? What's the name of this spot on the number line?
Isn't it like home or something?
Yeah, it's called the origin. Good job. So yes, the origin is the place that we begin all of our calculations and all of our movement. So what I want you to do is watch as I start here, and then I'm going to go to the first integer that's listed, and that's positive 4. So here I go to 4. And then I have to go backwards 5. So I'm going to scoop down and I'm going to go backwards 1, 2, 3, 4, 5. And where am I going to land at? I'm going to land at -1. Does that movement make sense to everybody? Where I move 4 in the positive direction and then backwards 5 in the negative direction? That makes sense? How about number 2 here? I'm going to start at the origin, and then I'm going to go to the first integer listed, which is -7. So here I go, back to -7, and then I have to go forward 2. So where did I land?
-5.
-5. Okay, how about this one, number 3? I'm going to go backwards 3, and then backwards 4 more, right? Where would I land if I did that? -7. Is it starting to make a little more sense here? Okay, I'm going to admit a couple more people that are coming in late here. You haven't seen that person yet. Okay. Let me clear my screen, and I'm going to pull my paper down just a little bit so we can see a couple more examples. Right here, 1 and 7 more. That's easy. Start at the origin, add 1, add 7 more. Where do I land? +8. Last one, go to the origin, add 3, subtract 12. So I have to go backwards. 3, 6, 9, 12. And where do I land for that one? -9, right? So we're going to look at these same problems, but use integer chips instead to demonstrate the same result. So when I'm using integer chips, I'm going to change a couple of these right here. Hold on. I want to change this one to be a subtraction sentence because that's a little bit more difficult to demonstrate. How would I represent this equation with integer chips? How many yellow chips would I put down? How many red chips would I put down? Anyone want to give me a hand with that one? What would I do?
You would put down 6 yellow chips.
Okay. Then what?
3 red chips.
Okay. But how do I find the answer? Like, how do I know what the answer is? So this is right, Santos, so far. You've demonstrated what I would put on my table, but how do I tell what the answer is? How do I know what the answer is?
You do 3 minus 6.
What do you mean? So these are, what are these worth? Anybody want to unmute? What are these things that I circled worth?
0 pairs.
There's 0 pairs, so they're worth nothing at all. So what do I have left over here? I have 1 positive, 2 positives, 3 positives. So therefore my
Positive
answer
3.
is going to be positive 3. And I don't have to write a plus, right? I just write a 3 to represent positive 3. What would I put down on the mat for this problem?
4 yellow chips,
Okay, 4 yellow chips, and then what?
5 red chips,
1, 2, 3, 4, and then let me grab the red ones. 1, 2, 3, 4, 5. And then what do you know about the 0 pairs? Can I cross anything out here?
the
Yeah.
0 pairs are worth
Those guys are gone, right? So what is the result? What am I left with?
-1.
-1, you got it. Okay, so this next one, I on purpose switched it to subtraction because I know you're going to encounter something like this on your quiz today, and I want to make sure that you know how to manipulate a subtraction equation and convert it into an addition one. Because watch as I try to model subtraction. I'm going to go put out my 7 red integer chips, right? And then if I go to pretend like I'm going to subtract or take away, I would have to take away 2 yellow chips, but I don't have 2 yellow chips to take, right? So I would have to introduce a couple sets of 0 pairs to make this work, or I could rewrite it as an addition sentence to support my ability to add in the integers I need. So if I introduced a 0 pair, would that change the value of this group? If I put in 1 negative and 1 positive, would it change the value of -7 at all? Or would it stay the same?
Stay the same.
It would stay the same because this is worth nothing. So I could put as many of these guys in as I want. As long as I put a red and a yellow together, they're worth nothing, right? So I could put in as many as I want. I needed 2 positives to take away, and now I do have them. So can I take away 2 positives? I can. So watch, I'm just going to cross out the 2 positives because I'm taking them away. And what do I have left over? 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives. Think of how this would play out on a number line. I would go to -7, and then I would go 2 more farther away, right? Would I land at -9? It would. So when you're working with integer models, use the chips and the number line to sort of gauge if your answer makes sense. And that way, I know sometimes the integer chips with bringing in 0 pairs gets a little tricky. So compare your answer to what would happen if you demonstrated on a number line, and I bet you would have an easier time. So if I rewrote this as an addition sentence, I would start with my first term, and then remember, add the opposite. Add the opposite. So if I was adding the opposite, -7 plus -2, look at, we've got it. The same model, -7 plus -2. Isn't that cool? So it doesn't matter which approach you take, you're still going to get the same answer, is -9. Okay, I'm going to go back to my integer operations slide for us to look at here briefly. Just review a couple of pieces of information before you go take your quiz. So we've talked about how integers are part of a number system that's bigger than it, and there are number systems that are smaller within it, but the integers specifically are all the whole numbers. So there's no fractions, no decimals, they're all whole numbers that are either positive or negative, and they could go infinitely. This set is infinite. They contain reflections of each other on either side of the number line. So the opposite of 42 would be negative 42. The opposite of negative 17 would be positive 17. So opposite just talks about the term or integer that exists on the opposite side of the number line from itself. So what again was the name of this position here, right in the middle of the number line? What's the name of this position?
The origin.
The origin, well done. So we do not say that 0 is necessarily positive or negative because it is the midpoint of the number line. It's neutral. We worked a little bit more with integers relating to positive and negative terminology. When I would give a scenario that included a positive word, for instance, the team had a gain of 10 yards on the play, then you hear that word gain and you know that they're moving in a positive direction, right? Because that word relates to a positive growth, a positive movement. And so you would assign an integer that is positive. You would say a gain of 10 yards, the integer that matches that is just 10, positive 10. But if you look at a situation that maybe contains a negative word, like the diver was researching at 50 feet below sea level. So when I say the word below, you're thinking that it is underneath the origin, right? Or lower than the origin. So you would have given a negative integer. So negative, did I say 50? Negative 50 would be the integer connected with that scenario. Same with these groupings of negative and positive words. You can utilize them to understand if it's a positive integer or a negative integer. All right, the last skill that we talked about was comparing and ordering integers. So comparing means that you acknowledge which has a greater value, which has a lesser value, or maybe if they are equal in value. So you'd be using symbols like this, or the equal sign to compare the two. We also talked about the term absolute value. And remember, absolute value is always what, everybody?
Distance to the number line.
It's always a positive number, right? Distance can never be negative. So we always acknowledge absolute value is just how far away is this integer from the origin. So we say it in terms of a positive value. How do you recognize that you're being asked to perform absolute value? That they have those straight absolute value bars around the term. Then lastly, we worked on ordering integers from lowest to greatest. And the technique we used, and feel free to sketch a number line if needed on your quiz, the technique we used is we looked at the terms that we had, we made an appropriate number line, plotted them, and then scanned from right to left or left to right, depending on if you were going from greatest to least or least to greatest, to find out the ordering of the integer teams. And then lastly, we worked on integer chips and number line models. And I think that our study in that has gone really well. Been very impressed with our work so far in that. Let me preview the quiz for you. I want to give you the last 10 minutes here to get rolling on it. What I'm going to ask is that you do not access the integer operations slide that we've been using as class notes during the test. I'd like you to just use your own intellect, please. The Chapter 9 integer quiz, which you will see once you open up your Google form, it says 30 points. Now, it's not going to be listed as 30 points in PowerSchool. I'm going to take half of the points. So it'll be a 15-point quiz. So if you got, let's say, 30 points on it on Google, you'll see 15 out of 15 in PowerSchool. So you'll still get the same percentage. I'm just going to take the amount of points and cut them in half because I think 30 is way too high of a value to assign to a quiz. So there's a couple of questions about integers and their opposites, absolute values, positive and negative words. And then I had this question in the last class a couple of times, so let's just take a look. Write the integer. So I'm asking you to write me a number, just type a number that describes the situation. I moved forward 8 spaces on the game board. So what integer, don't tell me, what integer, what number represents that particular scenario? So all you have to do is type a number right there. It could be a positive number, it could be a negative number, it could be 0, whatever number you think best matches that situation. And then we have a couple comparison ones. So you pick which symbol belongs between. Then this set of problems deals with sequencing. You can pick as many as you want that fall under this qualification here. Select all of the sequences that show integers in order from lowest to greatest, from least to greatest. So you would look through all of these, and if this sequence of numbers is lowest to greatest, then you can select it. You can select as many as you want. Now this one is greatest to least. So it's the opposite. You're going to be moving backwards through the number line and checking off which of these sequences fall under that quality. What's the value of a 0 pair? And then a couple of modeling ones. Which integer chip model represents the situation? Okay. Which integer chip model represents the situation? And a couple of number line ones. I will tell you that I have a small group of people from different classrooms that normally have their test read to them. I am going to be reading it to the group if you would like to move a little bit slower through the material at 11:30. So if you would rather not take it right this minute and maybe prep and study a little bit more, maybe if you haven't finished your Freckle Minutes, you can go do that. I sent an email this morning to people who haven't logged any this week. So I would maybe make an effort to remember if you have managed your Freckle Minutes or not. If you did not receive an email, you should be good to go. But if you want to take your quiz with me, you're going to have to come back at 11:30. So I'm going to stay on here for the rest of class. If you'd like to get started on your quiz, I'm here available for questions. And I will see you later if you would rather come back and do it with me at 11:30. Okay? So you open your quiz up in a new tab. Remember, there's nothing to submit for that classwork post that we did today. And I'm going to put myself on mute, and feel free to ask any questions that you may have along the way, okay?